So yesterday we watched a video about the Florida Everglades and the food chains that you can find in the Florida Everglades. And hopefully you found that the algae were the producer. Those producers were consumed by mosquito larvae, which are basically developing mosquitoes. Those would be primary consumers. The fish got its energy from mosquito larvae, which would make the fish a secondary consumer. The heron consumed the fish, which would make it a tertiary consumer. And the alligator consumed the heron, which would make it a top predator. Now notice that the arrows are showing which way energy is moving. And something that we haven't talked about, but bacteria and other decomposers, they're going to break down any dead and decaying matter. And so all of these things in the food chain, the algae, the larva, the fish, the heron, the alligator, will eventually die and decompose. So I can actually draw arrows going to from every single organism to the bacteria, indicating that the bacteria will eventually get energy and nutrients from all of these things once they die and they decompose. Okay, so I can take this food chain and I'm going to put it in something called an energy pyramid. Now this is on the back side of your sheet. And now an energy pyramid is a pyramid that shows the relative amounts of energy you would find at each level in the food chain. And so I'm going to put on the bottom of this energy pyramid the producer, the algae. So here's my bottom level of the pyramid. The bottom level of the pyramid is the largest level, meaning it contains the most energy. So if you were to quantify and give the amount of energy in every single level of the food chain a number, you would have the most energy in the bottom food chain, or at the bottom of the food chain. So algae were consumed by the mosquito larvae. So I'm going to write mosquito larvae. And mosquito larvae were consumed by the fish. And the fish were consumed by the heron. Now I know I don't have the alligator on here, but that's okay. So the purpose of this pyramid is to show that as you move up the food chain, there's actually less and less energy available to the next organism. And that ties back to something that was mentioned in the video. So when an organism uses the energy, well, when they consume something for energy, and they use up a lot of that energy for digestion and other processes, and they also lose a lot of the energy that they consume through heat. And so they mentioned that only 10% of the energy consumed passes on to the next link on a food chain, and we call that the 10% rule. So what that means is that if you were to give all of the energy in the algae here, those algae are consumed by the mosquito larvae, only 10% of the available energy is passed on. 90% of that available energy is lost during the transition from the algae to the larva. Okay, 90% of that energy, once again, is lost from the algae using it and from it being lost to heat. And so the question below asks, if 100,000 kilocalories, that's a unit of energy, are available to the producers in this food chain, that would be the algae, how much energy is available to the third trophic level? And so what I can do, I'm going to write on this box here and say that, well, the algae have 100,000 kilocalories of energy. It's asking then, how much would I find at this level and this level and this level as I move up the food chain? Now I need to take into consideration that every time I move up, 10% of that energy is going to be lost, and then 10% of the energy the next step, and then 10% again. So 10% of 100,000, an easy way to do that is to just take off 1 0. If you were to divide this by 10, which would be the same as finding 10%, you would get 10,000. That's 10% of the amount of energy that was available to the algae. So 10% of the energy moved up, 90% was lost. Now, of that energy that is in the mosquito larva, only 10% of that 10,000 is going to move to the fish. 10% would be 1,000 kilocalories. And if only 10% of that 1,000 is going to move up to the heron, I'm only going to have 100 kilocalories. And so you see, I lose 90% of energy every single step I move up the food chain. That means that you can't have food chains that are very long, because after a while you would have no energy left to support those predators near the top of the food chain. And so this kind of connects to this next idea. And this question asks, if there are 8 heron in this ecosystem, how many producers are present? And so I'm going to write above heron here the number 8 to indicate that, well, we have 8 herons. Now, to support 8 herons, you're going to need way more than 8 fish. And you can kind of think of this in a backwards way, because if you lose 10% of energy going up, that must mean you need 10 times as many things in the level below you. And so to support 8 of these herons, these big birds, you're going to need 80 fish. So I'm going to multiply by 10 as I move down the food chain here. To support 80 fish, you're going to need a lot of mosquito larvae, about 800 mosquito larvae. And if you want to support 800 mosquito larvae, you're going to need a lot of algae. Multiply by 10, I'm going to have about 8,000 algae. Now, this is all an approximation, but it makes sense if you think about how much food humans have to grow to feed all the humans on the planet. It makes sense that the lower you go in the food chain, the more of those things there need to be, and that's because of this energy loss that happens every step along the way. Okay, thanks for watching. That is energy pyramids.